Hello, everyone, and welcome to Group 7's presentation on Chapter 11, titled Enable and Practice Continuous Integration. In the previous chapter, we learned how it's important to create automated testing practices so that our developers get fast feedback for the quality of their work. Now, in this chapter, we cover area where more developers become involved and how they all work in different branches in version control. Branching was developed in version control so that developers could work on different parts of the software in parallel, but also enabling them to do so in a way that did not destabilize the project as a whole. However, when developers spend a long time working in isolation, this tends to be a bad practice because it becomes more difficult to merge everyone's changes back in a trunk. This problem grows exponentially as we expand the number of branches as well as the number of changes. This can cause developers to want to avoid merging code, thus pushing them to do it less often, and in turn making the merges in the future even worse. Continuous integration is a solution where developers will merge into the trunk as part of their daily work. Now we can talk about Gary Groover. He was the director of engineering for HP's LaserJet firmware division. It's the firmware that runs all of their scanners, printers, and multifunction devices. The team consisted of 400 developers throughout the world, and despite having a large team, the work they got done happened very slowly. The developers were unable to deliver new features as the market a customer desires grew. It was so bad that it got to the point where Groover would have the marketing team come to him with a ton of ideas, and he would say that they could pick two. Obviously, this was unacceptable. Groover estimates that only 5% of the developers' time was being spent on new features, and the rest of the time was being spent dealing with non-productive work and handling technical debt. Groover decided that he would implement a new goal of increasing the time spent on innovation tenfold, and that they would do this by using continuous integration, a large investment in test automation, and that they would create hardware simulator that could be run in a virtual environment, and that the developers could recreate the test failures on their own workstations. They also had a goal to develop new architecture that would support running all printers off a common build and release. In 4 years, Groover had one codebase supporting all 24 HP LaserJet product lines being developed on Trunk. He admits that this requires a huge mindset change for the team. He would have developers who moved from his project to different companies tell him how frustrating it was to not operate in an environment without continuous integration and the feedback it brings. The automated testing creates fast feedback and enabled developers to quickly confirm that their committed code actually worked.
Now, in order to produce more successful deployments in the development process, the batch of coatings need to be in small amounts of portions, just so it doesn't take so long to test them. Jeff Atwood, the founder of Stack Overflow site, observed uh, this relatable coding process, and he was able to split it up into either two categories. One is the optimization for individual productivity. He discovers that when everyone has their own private branch, they do their job the way that they prefer to, and they're able to do a whole lot of stuff without interfering with each other. However, near the end of the process where everything has to merge together, if everyone is not in sync, then the whole process could be catastrophic, and it could take 3 times as long to fix those errors than it would have if it was done in a team-based productivity. And then as the other category states, there's the optimization for the team productivity, where everyone works on the same thing. And then one, although everyone is on the same page, there is a major setback in which the commits are simplified to the point where they are easy to break the system. So one thing that Atwood uh, uh, hypothesized is that the chances successful merging is greater if the number of branches are a low number. The fewer the branches, the greater the success it would be. And also, it is a good idea to refactor the code base. That way, in the long run, it's easier to make changes. For example, the tall buildings on the western coast, um, well, the ones that were around for centuries, recently have uh, added shock absorbers on the bottom of the foundations, just in case if any more earthquakes to occur, the building will remain in place and it will not topple over. And it's because of that hindsight that there won't be further damage or greater damage in the future. So, in order to, this countermeasure for the large batch merging is to institute a continuous integration and adopt trunk based development practices. Now, what that means is that this is where all of the developers would check in their code to trunk at least once per day. Checking this code frequently reduces the batch size to smaller amounts, and because of everyone frequently checking the code, this would give the system time to be able to commit everything into trunk, and then in that we can run all the automated tests on this system as a whole, and if it does receive any alerts, then it would detect smaller, like these smaller merge problems, and then the smaller the problem is, the faster it is to fix it. It If you ignore those smaller merges, then later on, like a tree, it just grows into a bigger problem if it keeps going. So the smaller the problem can be detected, the faster it is to fix it and be in a good working state. Now, one of the benefits of using this trunk based development practice is that when you have frequent codes committed the to the trunk, there can also be um, methods implemented that can actually test and check the code to see whether it affects it as a whole. And we call these gated commits. So if a small piece of new code gets committed into the pipeline, it gets tested for everything to make sure that it doesn't ruin the trunk that's already in there. But if it does, then it can easily reject it automatically without any manual checks. And because of because of those commits, the trunk becomes a greater, higher quality system, and then with minimal errors and stuff, that also produces a faster deployment lead time. So the the more times you check your code, and and the more and the more tests that it passes and commits, the better the overall system is as a whole, and the faster it gets done. So think so we would modify our definition of done, stating at the end of each development interval, we must have integrated testing working and potentially shippable code demonstrated in a production like environment, created from trunk using a one click process. That's one click, and validated with automated tests. By adhering to these revised portions in the definition of done, This helps ensure that the code that is being produced throughout the entire process remains in an ongoing, testable, and deployable state.
In this half of our discussion on adopting trunk-based development practices, we're going to look at a case study of a company called Bazaarvoice. Bazaarvoice's business revolves around providing customer-generated content such as ratings and reviews for thousands of retailers, including companies such as Best Buy, Nike, and Walmart. In 2012, the company was driven by a monolithic Java application, which was made up of nearly 5 million lines of code, which went back to 2006 and spanned across 15,000 files. As they switched to an agile development style with 2-week development intervals, there was a large desire to increase their release amount from the 10-week schedule they were currently operating under. During this time, they had started to decouple parts of the monolithic application with the intent of breaking it down to microservices. So the first attempt of this conversion didn't go well, with 3 main problems being identified. The first problem was the lack of automation testing made any level of testing during the 2-week intervals inadequate to prevent large-scale failures. Second problem was the version control strategy, which allowed the devs to check in new code right up to the production release. And the final problem, main problem, were teams running microservices that were also performing independent releases, which resulted in issues during the monolith release or vice versa. They stabilized the monolithic conversations application deployment process by using continuous integration. In the 6 weeks that followed, the devs stopped doing feature work to instead focus on writing testing suites. They also changed to a trunk branch release model, where after 2 weeks a new dedicated release branch would be created with no new commits allowed unless an emergency occurred. The timeline of releases following these changes were startling to say the least. So at the first release in January 2012, after switching to Agile style, there were 44 customer incidents. March 6, 2012, with the release that was 5 days late, was matched with 5 customer incidents. Then on the 22nd of March, this release was on time with 1 customer incident, which was followed up by the April 5th release, which was on time with no incidents. So this serves to demonstrate the significant impact that continuous integration with the trunk-based model can have on a company's development practices. So then, onto the conclusion. Trunk-based development is likely the most controversial practice discussed in this book, described by the book itself. Many engineers will not believe it's possible, even those that prefer working uninterrupted on a private branch without having to deal with other developers. However, the data from the Puppet Labs 2015 State of DevOps report states trunk-based development practices predicts higher throughput and better stability with even higher job satisfaction and lower rates of burnout. While convincing developers may be difficult at first, once they start to see the benefits and pros of the switch, they will start to switch, as we've seen through the HP LaserJet and the Bazaarvoice examples. So continuous integration practices, they set the stage for the next step, which will be discussed later, which is the automation of the deployment process while enabling low-risk releases. So yeah, thanks for watching.